So remember that I got stuck on this question from the book uh, while working on this kind of a question because of this expression. I still have to resolve it. I hadn't had time to look into that. But what I did was that I created another question which has the same intent. And we cannot do that on an exam that just create a different question saying that it has the same intent. All right. So let's just work on a similar question here. That is, we have a right circular cone and a right circular cylinder. All right. And they contain fluid of the same density. And we have to show that the work done to empty the cone through the top is half the work done in emptying the cylinder through the top. So for the cone, let's look at a thin slab of the fluid here. And what we are going to do is this, that take this as the y-axis. And so we have this, we will take this as a height of y, that is the height of the slab is y. And let me make it a little better. Okay, and then we have, let's let the radius of the slab be r. Okay, and the height of this slab be h. Okay, so what we have is this then. So this slab has a thickness of delta y. So what we got is that the volume of that slab is pi r square delta y. All right, and now we have to write r in terms of y. So here I have taken half the cone from here to make similar triangles for you. And what you can see here is that r over h, okay, r over h is going to be the same as capital R over capital H. Or in other words, small r is going to be capital R times H divided by big H. Okay. Now, if you notice this here, that is how much is small h? That is capital H minus y. So what we got is that our R is going to be R over H and then capital H minus y. So that's going to be the radius r. Okay. And now remember this, the density is how much? The density is d. So this is the weight of the slab, and how much we are pulling it up by? We are pulling it up by h. So for the work, we will multiply it by h. And again, how much is small h? That's capital H minus y. So what is our work done? Pi d r square, here h, and then delta y. So now we have to do this simply, that we just have to integrate. We are integrating with respect to y from 0 to capital H. Okay, let's just put pi and d outside here. So we got r square h dy. Now remember this, that this h is capital H minus y, where capital H is fixed and r is this quantity. So let's just go to scientific notebook and figure it out there. So now we are evaluating this integral. So let's just go ahead and substitute these values that we had obtained in the previous screen. So this is going to be, that is for r, we got this quantity. So we'll just go ahead and square it. All right. And sorry about that. Okay. So we got then this quantity squared, and then we will change small h to what? capital H minus y. So that becomes capital H minus y, right? So what we have now is we got pi d. I mean, they're going to be proportional, but let's just keep them here. So here we have r square divided by h square, and then we simply have how much? We simply got h minus y cubed dy, right? So I'm just writing it in a typist way. I hope it's not confusing you. Okay, so this is cubed. All right. Now you can do this, just substitute for h minus y. You may take, say, u, and then what this whole quantity will become is, once you do the substitution, so after the antiderivative, this will simply be this, then h square. When you make cancellations, what the whole thing becomes then is this. We will have then h square. When we divide h to the 4 by it, we get h square again divided by 4. So that's the work done that we have for the cone. Okay, so here we got work done for the cone, and for the cylinder, it's going to be much simpler process. Let's take this as y-axis going through the center. So we have, as I said, we have a easier situation here, sorry. That is, we have this radius as how much? That's already r. So we don't have to do any work like we did here. And let's say if this height is h, or let me take it on the other side, or say this much is h, then and we will take this altitude as y as before, that this is y. Okay, so what we are doing is that now we have again, d is the density, pi r square, capital R square, dy or delta y is the volume. Okay, so this is the volume, and what we are doing is that we are again carrying it up by what distance? Capital H minus y, because that's what we are lifting it up by. All right. So again, what we have to do is that we have to get the integral from 0 to capital H in the same manner as before, pi d, and this time even capital R square. These guys will walk outside, and what you will have inside is the capital H minus y dy. Okay, and once you integrate it, what you will get is this. That is pi d r square h square over 2, which of course is twice this quantity, or the quantity here is half of this quantity. All right.